Ecuador 2026 holds inaugurates a new thematic session, Dendrochronology. This session is grounded in recent peer-reviewed research demonstrating how dendrochronological evidence can support environmental governance, forest stewardship, and informed decision-making, strengthening the link between tree-ring science and sustainable forest management. We sincerely thank all keynote speakers, invite speakers, and contributing authors for their valuable contribution, and all participants for being part of the international scientific exchange. To lead this global gathering, it is now my honor to introduce the conference chair, the founder and president of PEña-Ecuadendro Tropical Research, and researcher at the Institute of Geography Friedrich Alexander University in Germany. Please join me in welcoming Dr. Candidate Kelly Peña.
Okay, thanks, Rachel, for that nice introduction. There are collections distinguished experts and friends from all over the world. Standing here today, looking at participants joining us from 56 countries, I am reminded of why we started this journey. Ecuadendro was born in Ecuador in 2018 as a scientific space dedicated to dendrochronology and its disciplines. A place created to learn together, to collaborate across borders, and to build rigorous, meaningful research. From the very beginning, Ecuadendro was founded on a simple but powerful belief that the rings of a tree are more than just wood and cells. They are library of our planet history and more importantly, a compass for our future. For a long time, we as scientific have been excellent at reading the past, but today the world is asking us to help write the future. This is why we created Dendro Regulation 2. We are moving beyond the laboratory. We are taking our terrain increment, our terrain isotope, and our data, and we are placing them where they can truly protect our forests, in the heart of environmental life in governance. To the young researchers joining us, your words matter. To our senior expert, your guidance is our foundation. Together, we are proving that the tropical dendrochronology is not just a scientific discipline, it is a tool for global resilience. Thank you for believing in this vision. Welcome to Ecuadendro 2026. Let's make these 2 days the beginning of a new era in governance topics and management. So we will have a lot of interesting scientific topics. Please, Rachel, tell us about different kind of scientific research that we have here in this scientific conference. Tell us, please, Rachel.
Okay. In the session 1, Dendroclimatology, we have the following speaker and topics. Santosh Shah, with the topic Dendroclimatic Insight from the Kashmir Valley, Western India Himalaya, Progress and Potential. Narayan Prasad Gaire, with the topic Sensitivity and Response of Tree Species to Climate Change in Central Himalaya. Iris Castillo, with the topic Growth Response of Picia omorica to Climatic Variables in Southwestern Europe. Shirin Sultana, with the topic Altitude Control on Thick Tree Ring Climate Relationship in the Central Western Ghats, India. In the session 2, Wood Anatomy, we have the following speaker and topics. Mahmouda Islam, with the topic Wood Anatomical Variables as Climate and Environmental Proxies in Tropical and Subtropical Regions. Nelson Jim Barrios, with the topic Hydraulic and Anatomical Trade Variation along a Climatic Water Deficit Gradient in Common Amazonian Tree Species. Janbai Dema, with the topic drought resilience of jungles region in Thimphu, Bhutan, and southwest China, assessed through tree ring width and basal anatomical feature. In the session 3, Dendrochronology, we have the following speaker and topics. Neil Peterson, with the topic Testing of Forest Dynamics, Theory in Closed Canopy Forest, Honoring Cross-Dating in Forest. Andrei Popa, with the topic Spatiotemporal Variability of Dendrochronological Indicators in Pedunculate Oak, Quercus robur, tree ring across Europe in relation to species distribution models. In the session 4, Dendrohydrology, we have the following speaker and topics. Irain Jamil, with the topic Dendrochronological Potential of Pinus gerardiana for reconstructing precipitation and river flow variability in the Upper Indus Basin, Pakistan. Simon Bijac, with the topic Comparing Turkey and Pedunculate Oak Variability to Water Deficit, a case study from Southwest Poland. In the next day, in the session 5, Dendrogeomorphology, we have the following speaker and topic. Dambaru Balapkarel, Temperature, Topography, Elevation, Relationship in Mountains, Implication for Climate Analysis and Modeling. In the session 6, Dendroarchaeology, we have the following speaker and topic, Johannes Edvardsson. Cutting-edge dendrochronology, how we approach our cultural heritage with razor blades, drills, and saws. In the session 7, tree ring stable isotopes, we have the following speaker and topics. Ian Robertson, with the topic An Abrupt Climatic Event, different from the Bistelcon Pine Carbon Isotope Record. Luis Castruita Esparza, with the topic Dual Isotopes Delta 13 Carbon and Delta 18 Oxygen, indicate long-term physiological responses of Picia chihuahuana to climate extreme and increasing atmospheric CO2. In the session 8, Tropical Dendrochronology, we have the following speaker and topics. Ernesto Chains Rodriguez Ramirez, with the topic Examining Cambial Phenology and Tree Ring Chronologies in Tropical Mountain Cloud Forests. Mohana Morsalem, with the theme Variation in Population Structure and Seed Condition do not alter hydraulic strategies of Magnifera sylvatica, but underlying drivers differ across South Asian most tropical forests. In the session 9, Dendroregulation, this is a special focus 2026. Catherine Allen, with the topic Application and Policy Relevance of Dendrochronology. Kelly Peña, with the topic Recent Advance in Dendrochronology Focus on Climate and Environmental Governance. Malat Melek, with the topic The Dendrocopa Initiative, Advancing Dendrochronology and Forest Structure Analysis from Ecuador Tropical Research, in collaboration with the North Africa Research Fellowship. In the session 10, General Dendrochronology and Methodological Advance, we have the following speaker and topics. Justin Goma, we have, with the theme 5 years in the field, advancing Africa dendrochronology and build capacity.
Okay, thank you, Rachel, for explaining us and tell us about the interesting scientific themes that we will have in this interesting event. So in this way, Dr. Santos Sa, he is a senior scientist at the Verbal Science Institute for Paleoscience with expertise in terrains based in climate reconstruction of drought, floods, and hydroclimate variability across the Himalaya and Eurasia. He is a former president of the Asian Dendrochronological Association and has led dendrochronology research and training programs across South and East Asia. You are welcome, Dr. Santos Sa, with your topic.
Thank you. Thank you, Kelly. Hello, everyone. So, first of all, thank you very much, Kelly, for inviting me for this keynote talk in the second International Dendrochronology Conference, which we also call Ecuadendro. And last year also, you have organized first Ecuadendro conference, and this time, second time, you are organizing this conference. And I very much congratulate you for this success. And I can see many known faces here. My colleague Narayan, hello to you. And I can see the new chief editor of the Dendrochronology, Professor Johannes. Thank you very much for coming here. And I also congratulate you for the new chief editor of the Dendrochronology. And many known colleagues like Zhao is here, Jambe is here, and Malek, and many more. Thank you all the participants for joining us today for this talk. So, as Kelly already mentioned, I am Santosh Shah from Birbal Institute of Paleosciences, Lucknow, as India. And today I'll be presenting a dendroclimatic insight from the Kashmir Valley, Western Indian Himalaya. And I'll briefly discuss about the progress made so far by using clearing studies. And then I will also focus on emerging opportunities, like especially new proxies like blue intensity, and that can significantly improve our climate reconstruction from this region. So if you see where is the Kashmir? How can we remove? Sorry. Kashmir Valley is climatically a very sensitive region, which is located in the Western Himalayan region of India, and it lies in the intersection of the multiple atmospheric circulation system. So this makes a highly responsive to climate variability. Just provided a glimpse of the earlier studies carried out. These are from the Hughes et al. Studies, and he and his team carried out almost 10 different sites, mostly covering AB Spindro. And later on, and this study has been studied in year by this, like this one is in 1987, then again 1992, then again in 2001, and they finally reconstructed one summer temperature reconstruction of June to August, September, and also to June to August by just removing the July month. And this one is the stable isotope study, first stable isotope study carried out in not only in Kashmir Valley but also from the India. And this was carried by Ramesh et al. And this paper was published in Nature. And these are the chronologies we have prepared. So basically, first we have started the influence of how the influence of climate is in stable thereafter. So preliminary study shows training has a moisture signal. It has a limitation of the moisture, and it shows a very prominent signal with the drought. But it shows a negative influence of temperature on tree growth. So what we can observe with the blue intensity. So these are the blue intensity measurements carried out in clearings of epistensa. First, we scan the sample and we measure. This is Tanvir, one of my PhD student. He is also doing blue intensity study. And next year in 2027, we are organizing a global event that is INQA Congress. And this is the website of INQA. And we are also, and we have received 188 scientific session and 21 workshop. And I'm the science program committee convener of this INQA. And we also propose one session on treating, that is interdisciplinary treating research for spatiotemporal climate reconstruction. Our session is session 1.
Will make the presentation about the Dr. Narayan Prasad Gaire with the topic sensitivity and responses of the three species to climate change in Central Himalaya. Dr. Narayan Prasad Gaire is an associate professor at Tribhuvan University in Nepal and the founder and general secretary of the Tree Ring Society of Nepal. His research centers on tree ring-based climate reconstruction and environmental change in the Himalayas, including stream flow and temperature variability.
Once again, greetings everyone. Thank you, Kelly, for organizing such a wonderful event and providing us opportunity to share some of our research work in front of global audience. So in this talk, I am going to summarize some of the treating works carried out in the Central Himalaya or Nepal Himalaya with a special focus on some of the key species like Pinus Wallicana and also Abies spectabilis. So probably some of you are familiar and some of maybe not familiar about the position of the Nepal. Nepal is situated in the central part of the Himalaya, so we also call it the Central Himalaya. And country is relatively small, but we have a diversity in terms of the topography, diversity in terms of the climate. So it provides the opportunity for the different aspect of the environment change studies. We are also witnessing the different extreme in precipitation, temperature, and drought events. So all of this climate change and extreme is affecting the diverse sector, and Nepal Himalaya is witnessing the impact of the climate change in multiple sectors. So there are evidence of the impact on physical sector like rapid retreat of the glacier, melting of the snow, and also there is phenological changes in some of the growth of the species. We in this study we put few broad objectives and to study how multiple tree species or diverse tree species found in Nepal Himalaya are responding to this climate change and variability, and how different species are responding to this environmental change across environmental gradient. Earlier consecutive data gaps. So it provides us some challenges for the robust response analysis. Because of that, we extracted the gridded climate data from the CRU and also ERA5 data. So after collection of the climate data and development of the chronology, we calculate the growth climate response for the common period between climate and chronology, especially after 1901 to end of the chronology. So beginning of the development of the dendrochronological study in the Nepal, especially scholars from abroad contributed for the development of this tree ring field in the Central Himalaya. I want to remember the contribution of the Professor Akim Browning, Professor Amalak Bhattacharya, Professor Erliang, Dr. Santosh Shah, Professor Edward Cook, Marco Corrado, Anja Singh, Masaki Sano, and many more scholars from abroad who contributed for the development of this field in the only one chronology is millennial long chronology, which is from Sugadomocha, and some of the chronologies are longest for the species from the entire Himalaya, including the Abies spectabilis. If we see we try to see some pattern in the climatic response of the tree species along different latitude, longitude, and elevation gradient. So from the figure, you can see our Nepal's map is like rectangular with the we have the long longitude gradient compared to latitudinal gradient. So we analyze the response along the longitude gradient. And
Dr. Mahmouda, I need to give the permission for share. Yeah, okay, it's possible to share your presentation. You are welcome. And tell us about your recent advance. Okay, yeah, it's possible to see your presentation here. Yes, with full screen.
Are you seeing my presentation slide?
Yes.
Yeah, it's okay. That means one screen only.
Yes.
Yeah.
You can
Okay.
start.
Okay. Let me start. Okay. Hello, everybody. I am Dr. Mahmouda Islam, Professor Shahjalan University of Science and Technology. And today I'm going to talk about my topic. Wood anatomical features have been used as climate and environmental proxies in tropical and subtropical regions. Tropical forests comprise of nearly half of the world forest cover, and tropical forest response to climate have important consequences for global carbon cycle. Tropical tree growth, especially physiology, hydraulic behavior, affected by climate change, and especially tree records long-term historical growth and also physiological information in tree rings. Wood anatomy, especially xylem characteristics, are subsequently controlled by environment. Then, for many years, scientists believed tropical trees do not record climate well. This is because reasons are not very clear rings in the tropics, or not seasonality, not because seasons are not very clear in the tropics. In comparison to temperate boreal Mediterranean forest, tree ring study in tropical regions has not been developed that much. In tropics, although a number of tree ring studies conducted in South America, Asia, South Asia, Africa, but recent studies show that the T rings, especially a clear ring boundary, we can find in tropical trees. Cellular dendrochronology, our main topic is cellular dendrochronology. Cellular dendrochronology, that means focus on year-to-year variation in wood cell, mainly making the time series of wood's anatomical parameters. And this sector of dendrochronology not been flourished that much in tropics. So far, one of the pioneer tropical studies on basal chronologies of teak, published in 1999, Bhumi Nongjon et al. And Park et al. And these basal chronologies for Tectona grandis teak. Then in 2007, another study have done. Precipitation was reconstructed from 1743 AD, the early wood vessel chronology in South India. This is the Bhattacharya et al. Recently, some chronologies on wood anatomical features, mainly vessels, were developed in Mexico, Peru, Bhutan, and Himalaya. Even in temperate regions, cellular dendrochronology was successfully applied to a limited number of species like oak, beech, spruce, then chestnut, several pine species. Pandey and Zhang et al. Did two review papers, and they showed the rainfall and warming affect vessel size, wood density, growth, ring formation. They also explain how environmental factors, light and competition together control the wood development. And also, these studies support the use of wood anatomical features as reliable indicators of past and present climatic condition, subtropical forest. Morris et al. Also showed that percentage of total parenchyma tissue increase with mean annual temperature, and also increased with increase with altitude, but decrease with the annual precipitation, 1925 to 2015. The characteristics features of the xylem of two species are also studied in Bangladesh. This paper mainly focus on two species, Tuna ciliata and Lagerstomia species. Larger early wood vessels, larger early wood and smaller late wood vessels represent the ring porous species. Several vessel variables were measured and chronologies developed. And in this study, they found Tuna ciliata have influence on temperature more than precipitation. Hydraulic conductivity time series for three species were developed in Bangladesh. Ticracia tabularis, Tuna ciliata, Lagerstomia speciosa. All the chronologists are more than 80 years. Hydraulic conductivity chronologies. In also another species, plants, another species, the xylem adjustment, it means vessel features and hydraulic trait chronologies were developed. Xylem adjustment also depend on the vessel density and hydraulically wetted diameter. Very strong inverse correlation between vessel density and xylem vulnerability index.
Yes, okay. Perfect. Okay, so once again, I'm Irish Castillo, and the focus of this talk is growth response of Pizza Omorica to climatic variables in southeastern Europe. Well, understanding how climate affects tree growth in narrowly distributed conifers is really important, as we know, if we want to predict how these species will respond to climate change. So, in recent decades, the interior regions of southeastern Europe have warmed faster than before, with hotter summers and more frequent droughts. And one species particularly affected is Pizza omorica, or Serbian spruce. So this is a tertiary relict and narrow endemic conifer with limited regenerative capacity. It has weak competitive ability and increasing vulnerability to drought-induced mortality. Despite this, surprisingly, little is known about how this species actually responds to climate, specifically in the Balkans. So to address this gap, we conducted a dendroclimatic analysis of tree ringweed at Gobza in Bosnia and Herzegovina. We also complemented this work through a collaboration with Parthenope University of Naples in Italy to incorporate a biomass component into the study. And this is actually the first dendroclimatic biomass study of Pizza omorica in the Gobza site studies. And once the key climatic window was identified, we proceeded with climate reconstruction. This is guided by training from the Dendrochronology intense summer course at the University of Arizona's Laboratory of Tree Research that I attended. So we evaluated the model using standard calibration and validation steps, including split sample testing and residual diagnostics. And lastly, the final step involved estimating above ground biomass and associated carbon stock for Pizza omorica in Gobsa using IPCC compliant allometric equations. So linking this biomass estimates with the tree ring data helped us, interpret growth in terms of carbon sequestration and productivity and see whether growth biomass relationships stay consistent over time or shift under different climate conditions. And so this logged response suggests that conditions in the previous summer, it plays an important role in late wood formation in building up carbohydrate reserves, which then supports early wood production in the next growing season. We also found out that the tree ring chronology is highly reliable with strong coherence and signal fidelity, which supports climate growth interpretations. So in this figure, you see an individual series, for example, is compared with a master chronology. So despite some divergence in the mid-century, notably around 1957 in here, if you see, the overall correlation is 0.44, so it reflects strong agreement and validating the tree's inclusion in the site's chronology.
Okay. I will make your introduction. The topic that sitting speak today is about altitude control on terrain climate relationship in the central western Ghats, India.
Good afternoon, everyone. My name is Shirin Sultana. I'm from Cochin University of Science and Technology, Kerala, India. This work I'm going to present now was a part of my MSc dissertation, which I did from Indian Institute of Tropical Meteorology, Pune, India. So my presentation is titled Altitude Control on Teak Tree Climate Relationship in Central Western Ghats, India. Saratitimadi Nagarhole site is recording low temperature and higher accumulated rainfall. So this contrast of this climate is mainly due to the many factors like topography, their slope, their drainage and elevation, etc. This is the methodology that I have followed. I have followed the standard dendrochronological methodology, starting with sample collection. This is my guide, Dr. Sekat Singh Gupta, collecting samples from Central Western Ghats. We have collected almost 100 samples from both the sides, and then the samples were processed in the laboratory, starting with air drying, mounting and polishing. Then the samples were the rings were counted under magnification, and primary cross dating was done by skeleton plotting method. Then after that, the measurement of tree ring width was done using Lindap tree ring measurement system. To the tree growth climate relationship, so I have correlated with temperature, precipitation and soil moisture. So the Bhadra region, which is a high elevation region, is showing strong negative correlation between the tree growth and temperature maximum during pre-monsoon, March, April, May.
Dr. Nelson Jaén Barrios is an assistant professor at the University of Panama with a PhD in plant biology from Unicamp, Brazil, and research experience at the Smithsonian Tropical Research Institute. His work focuses on wood anatomy, dendrochronology, and silent hydraulics to understand plants' resistance to embolies across water availability gradients. You are welcome, Dr. Nelson, and you can start.
Thank you very much, Kelly. I really want to show you my presentation. This presentation is one chapter from my PhD thesis, and the title for that presentation is Hydraulic and Anatomical Tree Variation along Climatic Water Deficit Gradient in a common Amazonian tree species. But for a start, we are going to define what are considered abundant species. For considered abundant species are that species that have a really wide distribution, a high density. For Hans, 2013, he defined that species that have really wide distribution in the Amazonian region, resistant. In this trait is the most common for the use or try to understand the resistance in the P50. I'm going to explain better more ahead. In the Amazon, hydraulic trend can explain other things like species principal, like species distribution, and mortality principal, like mortality pattern. One of the most common or the major modulator in the variation principal in hydraulic trait is the climatic water depth. Another trait that we are using for trying to respond our question is the vessel density. We expect it to happen the water availability increase, the vessel density decrease in this way. The other question is how hydraulic trait is correlated with vessel trait along a gradient of water availability. Our main question is that across all our gradients, we expect to have that vessels with characteristics like higher vessel composition, higher vessel lumen fraction, is related with more efficient hydraulic conductivity and low hydraulic embolism resistance.
your introduction. The topic from Jambai Dema is related on drought resilience of jungla regia in Thimphu, Bhutan, in southwest China, assessed through terrain width and vessel anatomical features. Jambai Dema is a PhD student of the Xiwanbana Tropical Botanical Garden, Chinese Academy of Science, specializing in dendrochronology and drought resistance of vino species. Her research combines extensive fieldwork in Bhutan and China with quantitative analysis to understand tree resilience, particularly of angiosperms in biodiversity-rich mountain region. You are welcome, Jambai.
Pleasure to present my research on drought resilience of Juglans regia in Thimphu, Bhutan and southwest China, assessed through the tree ring width and vessel anatomical features. For the tree ring data, we obtained 30 trees per site, and then we followed standard dendrochronological processes to analyze the data. And finally, we use our software to analyze our data. And for the wood anatomy, we selected the 10 samples that were previously used in treating, and then we scanned using a smart zoom, and the visibility of the vessel were improved using Adobe Photoshop, and later the quantitative wood anatomy was quantified using the Roxas software, so on. And in our study, we found that trees in Jingdong and Dodena experienced a greater decline and a higher growth rate after the drought, and these two sites are located in the south-facing slope. And especially in the trees in Jingdong site, that's in Yunnan site, it experienced a greater decline in the first year of drought. However, they also recovered higher recovered. And for the trees, all the trees in all the sites, there was less than 50% recovery after the first drought year.
The next session is related about dendroecology in the session number 3 with a keynote from the Dr. Neil Peterson with a team testing of forest dynamics theory in closed canopy forest, honoring cross-dating efforts.
Thank you. I'm really happy to be here. Good morning, good afternoon, wherever it is in your part of the world. I'm really happy to be here again this year. And so many thanks to the organizers, especially Kelly, for making this happen. I really enjoy this gathering of tree ring scientists from around the world. What I'm going to talk about today is how we can maybe better test forest dynamics theory in closed canopy forests in ways that takes advantage of the strength of dendrochronology, the precision of cross dating, and to honor those hard efforts, as we just heard about, in terms of cross dating trees. And the place in the context for today and why this is important, I think, is we are seeing the very significant impacts of global ecological change around the world. I like to point to the semi-arid forests because this has been happening for two and a half decades or so now, where we've seen an increase in the intensity, frequency, and scale of forest fires, pine beetle outbreaks killing trees, and a mega drought that is killing some species over others in the southwestern United States. The impact of global ecological change. So our understanding, our theoretical underpinning, and what we've observed in the last 50 to 100 years in the eastern United States is that broad-scale change might be low with climatic change as we move into the future. There are models that suggest that we could get significant change in our forest over the next 20 to 50 years, but there's almost an equal likelihood that the forest won't change too much in terms of climate change and natural disturbances. Call out any scientists or any specific study, but here's one from about several decades ago. And in the early part of this record back here, it's a periodic disturbance, but I think that's sample replication. This is only one forest as well. But starting at around 1850, going to about 1960, you can see there was rather continuous disturbance, the trees showing a growth release or a canopy disturbance on the y-axis is pretty consistent. The abrupt increase in the 20s and 30s is actually an exotic pest and pathogen, probably killing off the American chestnut. And so important, if we have annual cross dating and we put great efforts to cross date, we should honor that. We should reflect that in the data. And so I felt very strongly that we should use annual binning. And this is the result that we get from those efforts in terms of binning the data differently. And I love winter. So here's our network of old growth forests in the Adirondacks. We sampled 12 forests. We only worked up 9 of these forests because the other 3 were highly disturbed by exotic pests and pathogens or a big fire about 80 to 100 years ago. We have a roughly 1,300 growth series, and we have 700 to 900 trees. We're still finalizing our data there that we have processed. We sampled 13 different tree species, so this really isn't one of the more diverse parts of the Eastern United States, but I was really surprised we sampled 13 tree species. The oldest tree dates to 1572. The oldest sugar maple, Acer saccharum, is 348 years old, which is really old.
So you are welcome, Dr. Andre.
Hello, everyone. Thank you for this nice introduction. As mentioned, my name is Andrei Popa, and I'm currently working as a postdoctoral researcher in the National Institute for Forest Research in Romania. Before I start, I want to acknowledge all the authors. There was a big effort in putting this network together. As you see, it was a core team which helped me in analyze the data and writing the research, the manuscript. But it was really important, the effort from the others. It was more than 40 people from 11 countries which submitted the data to this study. And in the following, I'm going to present briefly the results from our research. Before I start, I want to acknowledge all the authors. There was a big effort in putting this network together. As you see, it was a core team which helped me in analyze the data and writing the research, the manuscript. But it was really important, the effort from the others. It was more than 40 people from 11 countries which submitted the data to this study. And in the following, I'm going to present briefly the results from our research. To do this, we calculated the climate relationship in an early period, which was 1950, 1985, and in a late period, considering that the climate change started around 1980s or so. And we make the difference between the correlation in these 2 periods, and we consider temporal shift in climate sensitivity based on this difference. In terms of results, I will initially start with the results for the current growing season. In the current growing season defined from early spring to late summer, we checked if the highest correlation in the absolute term was significant or not. And in terms of climate-water balance, we see that in 80% of the plots, we obtain a positive and significant correlation between the climate-water balance and oak growth, while the negative correlation between the temperature and oak growth was significant only in 50% of the plots, which were mostly in the southern part of the network, corresponding to the contraction area, to the area where the oak in the future is not going to be able to grow anymore. Regarding the correlation between the vapor pressure deficit and the oak growth, in the current growing season, we observed a negative and significant correlation in more than 65% of our plots. And again, it was more present in the southern part of the network, but also in the northern part. Looking at the dormancy season, we observed.
Ibrahim Jamil. I did my bachelor in forestry from Pakistan Forest Institute, Peshawar, and now I'm doing my MS in climate change and sustainability at the School of Interdisciplinary Engineering and Sciences from the National University of Science and Technology. So, are you getting my second slide? Is there
Yes.
anyone?
Go ahead.
Okay. Okay, thank you. So the background and motivation of this study is basically lies in the fact that the Indus River Basin, which support the largest irrigation system in the world, and it's the main source. The Indus River, it is the main source of Pakistan irrigated agriculture system, particularly in the plains of Punjab and downward streams. And I would like to add that agriculture is the largest sector in Pakistan economy, and it accounts for 24% of our GDP. And agriculture products such as cotton, rice, sugar, etc., which have a very great companies and industries here in our country, it contribute about 70% to the country foreign exchange earnings. The instrumental river discharge in the climatic record in the upper Indus Basin typically spend less than 100 years, limiting the long-term hydrological assessment. And we plan the study's variability. So this study is basically evaluates the dendrochronological potential of Pinus gerardiana for reconstructing historical hydroclimatic conditions in the upper Indus Basin. And then we will be able for the better for the better hydroclimatic assessment and its future variability or its scarcity. So the objectives of our studies mainly was to evaluate the climate growth relationship of Pinus gerardiana, and we also go to assess its potential as a proxy for precipitation variability in the major Indus basin, that is Chatral. And alternatively, we would find out the river flow variability in the Indus River. And as I stated first, that Indus River, this is the backbone of Pakistan agriculture system. So you people may see my screen, and there is but we have carried out the simple correlation analysis for all the listed climatic variables. But the major and significant factor climatic variable that affect the growth of Pinus gerardiana was precipitations. And you people may see in it that the significant positive correlation has been observed for the Pinus gerardiana, where the R values is for the previous June the R value is 0.5052 and the P value is less than 0.01. For previous March precipitation, this value is R value is 0.369. You people may getting my screen. And the P value is less than 0.05. And for the current June precipitation, that is 0.425 and P is less than 0.025. By the use of Dendro tools, this is my
Dr. Simon Bayjak. About the doctor, he holds a PhD in forest science and it's a lecturer at the Warsaw University of Life Science in Poland. His research focuses on the effect of climate conditions on the growth of non-native tree species introduced into the Polish forest, as well as on the influence of natural and anthropogenic disturbance on tree growth dynamics. You are welcome, Dr. Simon.
Thank you very much. I hope you can hear me and see my screen.
Yes, we can see your screen and we can hear you.
Okay, so the topic is comparing two oak species, one native and one introduced one. Why we focused on this issue? We have different types of species, local native ones and so-called non-natives or alien species. Some are introduced from other continents, but some species which hold this title can be originated from not so far away. And there is a constant debate about shifting ranges, which species will be a winner or loser in terms of predicted climate changes. And it is good to recognize the potential of acclimatization of different species in terms of considering future species structure of our forests and those trees. And which was what was very helpful for further studies. Once cores were mounted on the sticks, their surface was leveled with a microtome, which ended with a very sharp picture, and the measurements were very easy. And it will be also helpful for our next steps, which include wood anatomy studies. Was used. We used also this climatic water balance, which was calculated for April-September period as a period, growing season period. We use this parameter to detect drought events. We standardized these climatic water balance values, and any value which fall below minus 1.5 was considered as a drought event, and we detected 5 such events: 1992, 2003 and 4, and 2015 and 16. As you can see, the non-native species were more prone to the influence of temperature, especially in previous growing season, which is at the bottom. Which is on the top of those panels. As far as the water issues are concerned, precipitation and climatic water balance, we can see that both species exhibit quite a similar dependence on those parameters. However, for Quercus robur, so the native species, we can see that this response is a little bit weaker. So stronger impact of precipitation and climatic water balance on Quercus ceres.
We are in our last part of our scientific meeting today. Was very nice have the opportunity to know, to listen, to see the different scientific research that our college are working. This is very interesting because our perspective could improve. We can apply other methods, other way to achieve our results, to improve and try to find other or more collaboration, because these meetings is served for this. Thank you very much, say the Dr. Robertson. Okay. Neil say thank you too. And yeah, perfect.
Hello.
Okay, we are here. Yes.
Hello, thank you very much.
Thank you.
It was a great presentation.
Dr. Katarina Kafur from Triring Society say thank you. Okay. Thank you too for assist to our conference. And see you tomorrow with more interesting and very, very important topic about dendrochronology and its disciplines. and we will see you tomorrow.